Just like the last example that we did, we're asked here to determine if Rolle's theorem applies, and if it does, find all the values in the interval where f prime of c is 0. Okay, so here our function is f of x equals x to the third minus 2x squared minus 8x, and we're on the interval from -2 to 4. So just like in the last problem, first thing I'm going to check is f of a equal to f of b. In other words, is f of -2 equal to f of positive 4. You might want to pause the video for a moment and compute those, because when you do, you're going to find out that f of -2 is 0, and when you plug in f of 4, it's also 0. So condition number 1 is satisfied here. F of -2 is equal to f of 4. And then we continue on. Is our function continuous? Well, continuous means it has to be defined, and the limit has to exist through that whole interval -2 to 4. Well, we're dealing with a polynomial. Polynomial is continuous everywhere. Doesn't have any division by variables, doesn't have any even roots. It's not a trig function which can have its own limitations or anything like that. So yeah, this is continuous everywhere. And then we ask, well, is it differentiable? That's where our last problem kind of fell apart. Well, let's talk about the derivative. Let's compute f prime. F prime is a derivative we can compute rather easily. 3x squared minus 4x minus 8. And so is that defined for everything in -2 to 4? And the answer is yeah, it is, because it's a polynomial, which is defined everywhere. And so therefore, we have met all three conditions for Rolle's theorem in this example. And so there we say Rolle's theorem applies. Now the second part of the problem is, okay, Rolle's theorem applies, what values in the interval, what points in the interval lead to the derivative here being equal to 0? That's what Rolle's theorem guarantees. What are those points? There has to be at least one, but there could be more than one. It just depends on the problem. So we decide, when is f prime equal to 0? When is f prime equal to 0? 3x squared minus 4x minus 8. 3x squared minus 4x minus 8. When is that equal to 0? I'm just going to go straight to the quadratic formula. This thing actually doesn't factor. That's fully a possibility as you're doing this, that you're going to run into something that doesn't factor. So I use my quadratic formula, which recalls -b plus or minus square root b squared minus 4ac, all that divided by 2a. All of that divided by 2a. Okay, and so I want to know what that is. So I plug in my coefficients for my equation. I get the negative of -4 plus or minus the square root of -4 squared. -4 squared. Minus 4 times 3 times -8, all over 2 times 3. And what I usually do with the quadratic formula is I just simplify this piece inside. So work that out. 4 squared, -4 squared would be 16. Minus 4 times 3 times 8 is actually going to be 96. And then we're going to get 16 plus 96 is 112. So to clean this problem up, I do need to simplify that square root of 112. So I'm going to reduce that by saying, well, 112 is 16 times 7, 16 being a perfect square, so that's why I'm pulling it out. Square root of 16 is 4, so it's 4 square roots of 7. So now I'll go back to the problem and plug that information in. X equals 4, because -4 would be 4. Plus or minus 4 square roots of 7, and then 2 times 3 in the bottom there becomes 6. And then let's just simplify that just a little bit further. I can break that apart as 4 over 6, plus or minus 4 square roots of 7 over 6. Both of those will reduce, so I get 2/3 plus or minus 2 square roots of 7 over 3. Now that's two answers. Those two answers only apply if those two answers are both in that interval -2 to 4. So one of the things you do have to verify, and this is where you can just go to a calculator here and do some quick computation. What are those values? Where do those numbers fall in relation to negative 2 to 4? It turns out 2/3 minus 2 squared roots of 7 over 3 is around negative 1, but it's definitely bigger than negative 2 and smaller than 4. And when you do 2/3 plus 2 squared roots of 7, that's somewhere in the neighborhood of around 2.5, positive 2.5, which is also in that interval. So they do both fall in the interval, so there's actually 2 points in the interval between negative 2 and 4 in this example where the derivative is actually 0. So turns out both of those do apply. So both are in that interval, so both are solutions to that problem.